Welcome back to Flash Friday with Len. This week is the second half of a two-part series where we will be discussing the detailed warning label for arc flash and shock. Last week we discussed the shock protection boundaries. This week we will be discussing information related to arc flash, including the arc flash boundary. As mentioned last week, our goal here is that you will be able to interpret the information found on these labels so that you are best prepared to protect yourself and others from electrical hazards. As you recall from last week, the information contained on the label, regardless of arc flash or shock, applies to when the doors are open or when a cover is off the electrical equipment, such as a disconnect switch or a circuit breaker panel. An arc flash is an unintentional release of energy caused by an electrical fault. Some characteristics of an arc flash include hot molten metal, flying shrapnel, smoke, and intense heat. An arc flash event can reach up to 36,000 degrees Fahrenheit. Unlike the limited and restricted approach boundaries for shock, which are directly related to voltage, arc flash information is based on engineering calculations, known as an incident energy analysis. An incident energy analysis is a component of an arc flash risk assessment used to predict the incident energy of an arc flash event for a specified set of conditions. These conditions include distance, available fault current, and time. Here, time refers to the instantaneous clearing time of an overcurrent protective device. When it comes to arc flash and arc flash protection, there are three pieces of information that we need to discuss: the calculated incident energy, a given distance, and the arc flash boundary. The calculated incident energy is the amount of thermal energy impressed on a surface of a certain distance from the source that is generating an electric arc event. It is typically expressed in calories per centimeter squared. For instance, if the label indicates 5 calories per centimeter squared, a worker would want to dress to at least 20% greater than this amount of incident energy. Please refer to Table 3, found in the 2021 edition of CSA Z462, for the correct selection of arc-rated clothing and other PPE when the incident energy analysis method is used. Typical working distance in an arc flash hazard area are 18, 24, or 36 inches, depending on the type and the physical size of the electrical equipment. This distance is measured from inside the equipment to when arc flash could occur. The arc flash boundary is again a calculated distance. This distance is where the incident energy has been reduced to 1.2 calories per centimeter squared. This amount of incident energy is the amount of heat required over a span of 1 second to produce a second-degree burn to bare human skin. Remember, if one is working within the arc flash boundary, you must be dressed accordingly to the calculated incident energy. If the arc flash boundary happens to be a greater distance than the limited approach boundary for shock, the arc flash boundary then becomes your outer limit of approach. Well, that's all for this week on our lessons on electrical safety. Thank you again for joining us, and please be sure to join us again next week.